The representation of multiplication of integers on the number line. So we have to represent the multiplication of integers on the number line. So already you know, suppose 2 is an integer, 3 is an also integer. So 2 multiplied by 3, what is the product? You know that is 6. 2 multiplied by 3 is equal to 6. So you see, multiplication is the repeated addition. So you see, if 2 is added 3 times, so we get 6. So you tell multiplication is the repeated addition, but we have to show it. So this on the number line. So you see, using the ruler, you just represent a number line. Like this. And so on. And you see, already I have told you, this is the point 0, and towards right, it is the positive direction, and towards left of 0, it is the negative direction. So you see, what is 2? Here it is 2 on the number line. So we have to show these 2 units first. So it will be repeated 3 times. Like this. So already 6 is here. So 6. Suppose I am going to minus 2 into 3. That is equal to minus 6. Already you know it, but we will have to show. So you see, already I have told you that these are the unit distances, and each unit distance is of equal length. So towards the left of 0, you mark like this: minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, like this. So minus 2 is repeated 3 times. So what is minus 2? This length. So towards the negative of 0, this is minus 2. Again we take 3 times. And do 6. And you see here it is minus 6. Okay? So minus 2 multiplied by 3 is equal to minus 6. So this is the representation of the multiplication of integers on the number line. Okay? So now we have to represent the division of integers. Just I erase it. Division of integers. You see, what is division? That is the repeated subtraction. Division is the repeated subtraction. Suppose you see, 6 divided by 2 is equal to 3. 6 divided by 2 is equal to 3. So 6 is the dividend, 2 is the divisor, and 3 is the quotient. 6 is completely divisible by 2. So here there is no remainder, remainder is 0, and we will get the quotient as 3. So what does it mean? How many 2's are present in 6? The 3. There are 3 2's. So 3 2's are added to itself to give 6. So how many 2's are added to give 6? Yes or no? So how many 2's are added? The 3 2's are added to give 6. And you see how division is the repeated subtraction. So 6 was the dividend and 2 was the divisor. Just to subtract, this is 4, then we subtract, this is 2, then we subtract, this is 2. You go on subtracting till we get 0. That is the remainder. So it is once, it is twice, and it is thrice, 3 times. So here it is that 3. So we have to show it, we have to represent it on the number line. You see, using the ruler, using the line. Okay? Like this. So 6 divided by 2, we will have to show it. Here it is 6. Okay? So how many 2's are there? So I have to pick 2 first. And I have to come to this 0. Where it is? Where it is? And the number line you see here it is. So it is 1, 2. It is 6 divided by 2 is equal to. So how many 2's? This is 1, 2. This is another 2. This is another 2. So you see 1, 2, 1, 3. So 3 2's are there. 3 2's are added to itself to give 6. So like this we can proceed. Suppose I will write minus 6 divided by 3. Okay? Minus 6 divided by 3. So, okay, let us now study on properties of integers under different basic operations under addition, subtraction, multiplication, and division. So we have to see the properties of integers and the basic operations we have to follow: addition, subtraction, multiplication, and division. So you see, what do we do with the numbers? When we need, we may add, we may subtract, we may multiply, or we may divide. So these are the basic operations. So first, closure property. Closure property. And you see, for addition, I give this sign. This is for subtraction, this is for multiplication, and this is for division. So closure property. So what do you mean by closure property? Are the integers closed under addition? Are they closed under subtraction? Are they closed under multiplication and then under division? We will see. So we will check. So closure property. What is closure property? You see, suppose two integers, and you do the basic operation addition. So if you add two integers, if the sum becomes an integer, then it shows the closure property. That means it is closed. Suppose I will take 3 and 5. These are two integers. I am adding. So 3 plus 5 is equal to 8. So sum is 8. 3 is an integer, 5 is an integer, 8 is an integer. Yes or no? So the sum is an integer. So closure property, the integers show closure property, they are closed under addition. So I give a tick mark here. I give a tick mark here. Then for subtraction, suppose 3 minus 5. That means that is 3 plus of minus 5. I may write like this. So what is the result you see? So two integers of opposite signs are added. What will we do here? We will take the numerical difference. So 5 minus 3, that is 2. And the sign with the higher numerical value, we will assign that sign to the sum. Or here we have taken the difference between the two numericals values. So this is minus 2. And you see, 3, it is an integer, 5 is an integer, and here minus 2, it is also an integer. So we can tell the integers are closed under subtraction. Then come to multiplication. 3 into 5, that is 15. You see, 3 is an integer, 5 is an integer, and 15 the product. It is also an integer. So I give a tick mark here. Then come to this. If I write 6 divided by 2, 6 is an integer, 2 is an integer. These are two integers. I divide 6 by 2. So here the quotient is 3. So 3 is an integer. But if I divide 2 divided by 6, if I do like this, so this will be 2 upon 6, that is equal to 1 upon 3. 1 divided by 3 or 1 upon 3. So you see, 2 is an integer, 6 is an integer, 1 upon 3 is not an integer. So, all the integers are not closed under division. All the integers. You see, 6 divided by 2 is equal to 3. Here it is okay. But if I take 2 divided by 6, then the result is, the quotient is 1 upon 3. So, that doesn't hold good in this case. So, what we can write here? And you remember this, not for all integers. I give a cross mark here. That means all the integers, they are not closed, they do not show the closure property under division, under this operation. So we may write all the integers are not closed or do not show closure property. You may write like this, or are not closed under division. Under this operation, they are not closed, but they are closed under, all the integers are closed under which basic operations? Under addition, subtraction, and multiplication. All the integers are closed under addition, subtraction, and multiplication. Because I have written here all. In case of division, some integers, they are successful in giving another integer. But not all. Like 2 divided by 6, what we did, that is 1 upon 3. It is not an integer. It is not an integer. Not an integer. So we can write and remember it. All the integers are closed under addition, subtraction and multiplication. Just you work it and remember it. Let us move to next property. Commutative. Commutative property. And this commutative property, you may tell commutativity, single word. What is commutative property? That is also called commutativity or order property. Or order property. Suppose we will take two integers 5 and 3. So you see, if you write 5 first, then 5 plus 3, this will be 8. And again you change the order of the integer. So in the first place there was 5, and in the second place there is 3. So bring 3 first, then you write 5. So 3 plus 5 is equal to 3. So what did we know? 5 plus 3 is equal to 3 plus 5. 5 plus 3 is equal to 8 and 3 plus 5 is also equal to 8. So left hand side 8 and the right hand side that is also equal to 8. So what we knew? All the integers, they show commutativity or they show the commutative property under addition. So I am giving a tick mark here. Next, we will take two integers and we will test the basic operation subtraction. You take away 3 out of 5, 5 minus 3, and you see, you take away 5 out of 3, that is 3 minus 5. Just I am changing the order of the integer. 5 minus 3. Whether it is equal to 3 minus 5 or not, I have to see. So you see, this is the left hand side or not. I cannot write here whether it is equal or not equal. Just you see, 5 minus 3. What is this value? That is equal to 2. And what is 3 minus 5? That is equal to 3 plus of minus 5. And you follow the addition rule. So this is minus 2. So 2 is not equal to minus 2. So the integers, they do not show commutativity under subtraction. But in case of multiplication, what happens? You see, 5 into 3, that is equal to 3 into 5. 5 into 3, that is 15. The product is 15 here. Here it is also the product is 15. So left hand side is equal to the right hand side. So 5 into 3 is equal to 3 into 5. So integers, they show the commutative property under multiplication. Do they show the commutative property under division? Now we have to prove it. Suppose 5 divided by 3, and you see 3 divided by 5. So 5 upon 3 and it is 3 upon 5. You see, 5 upon 3, it is improper fraction or not, and this is a proper fraction. You see, they are not of same value. The value is not same here. So what we knew that the integers show commutative property or show commutativity under addition and multiplication. So we may write all the integers so commutativity under addition and multiplication. So you have to remember this.